Good afternoon, class. So, last lecture we have started the topic that is antagonist. So, the drugs which bind to the receptor and they block the activity of neurotransmitter. Such drugs they are called as antagonists. So, we have started anti-adrenergic drugs. They are also called as sympatholytic drugs, or they are called as adrenergic antagonist drug. Okay. So, regarding the alpha antagonist, okay, so we have classified these alpha antagonists into two types, that is the selective alpha 1 antagonist or selective antagonist, and second one non-selective antagonist agents or non-selective alpha adrenergic agents. Okay, so the selective drugs, they binds to the particular receptor. So these drugs, prozosine, terazosin, they are alpha 1 selective, so they binds to the particular alpha 1 receptor and they will block the activity of a alpha 1 receptor. So such drugs, they comes under the selective anti-adrenergic agents. They are selective against the alpha 1 receptor. So they block only the alpha 1 receptor. They will not block alpha 2 or any other receptor. Then next class of the alpha adrenergic antagonist, that is the non-selective. So these non-selective, they are classified into two types. So again, non-selective means they are not selective for the particular alpha 1 receptor or alpha 2 receptor. So they can block alpha 1 receptor as well as they can block alpha 2 receptor. So there is no selectivity for such drugs to which receptor they have to block, alpha 1 or alpha 2. They may block alpha 1 as well as alpha 2 receptors. So what happens due to the non-selectivity? So due to the blocking the alpha 2 receptor also, so they will show the effects which are related with the alpha 2 antagonist. So that's why the selective drugs are generally preferred over non-selective, because they will show the particular effect. जी ऍक्टिव्हिटी आपल्याला पाहिजे तीच ऍक्टिव्हिटी फक्त आपल्याला सिलेक्टिव्ह मध्ये दिसते. शी शो द पर्टिक्युलर इफेक्ट. दे विल नॉट शो एनी काइंड ऑफ अदर साइड इफेक्ट्स or other effects which are associated with the other receptor. Okay, so these non-selective, they are classified into two types. It is the reversible non-selective alpha adrenergic antagonist and irreversible non-selective alpha 1 or the alpha antagonist. Okay, so what is the difference between the reversible and irreversible? So reversible means they will block the alpha receptor, and after some times when there is a completion of activity, they will detach from the receptor, and when they will detach from the receptor becomes free, so another neurotransmitter that can bind to that receptor. Okay, so what happens, suppose this is receptor and this is drug. So this is receptor, this is drug. So what happens, this drug binds to the receptor. When they bind to the receptor, they will block that receptor. So neurotransmitter, it may be the epinephrine, norepinephrine, they cannot bind to this receptor. It is difficult for them to bind to the receptor as drug binds to the receptor. When the activity over, what happens, this drug detaches from the receptor. So they remove or they are released from the receptor. So drug becomes separate, receptor becomes separate. So here the drug receptor interaction takes place. After some times when activity is over, drug remains separate, receptor remains separate. So to that receptor, the agonist drug or neurotransmitter, they can now bind to that receptor. So that is the difference between that is the reversible inhibitor. But what happens in case of irreversible? So when drug binds to the receptor in irreversible, then after some time also the drug remains in the contact or it having the interaction with the receptor. It is not detaches from the receptor. So there is an interaction between drug and receptor takes place. So that is the irreversible. So it is here also adrenaline cannot bind to receptor also. After some time also adrenaline cannot bind to the receptor as this receptor is blocked by the drug for the longer duration of activity. So it is difficult to separate the drug and the receptor from each other. Okay, so that is the difference between the reversible and irreversible. In the reversible, after some time, drug can be detached from the receptor. So neurotransmitter can bind to the receptor, it will perform its activity. But in case of irreversible, what happens? Drug binds to the receptor and the permanently blockage of that receptor takes place. So it is difficult for the neurotransmitter to bind the receptor. So such kind of drug which are irreversible, they can produce their activity until 3 to 4 days. They can show their activity 3 to 4 days because they block the receptor, so it is difficult for them to detach it from each other. And when this strong interaction takes place, or when they causes irreversible, when there is a strong interaction between drug and receptor, and that strong interaction is nothing but the covalent bond. दोघांच्या मध्ये जर कोव्हॅलंट बॉन्ड असेल तरच त्याचे स्ट्रॉंग इंटरॅक्शन असतात. आयनिक बॉन्ड असतील, हायड्रोजन बॉन्ड असतील, वॅन्डरवॉल फोर्सेस असतील, these are the weak forces or weak bonds, so they can detach it from that receptor. But in case of this irreversible, there is a formation of covalent bond takes place, and due to the formation of covalent bond, it is difficult to detach the receptor and the drug. That's why it generally binds for the receptor for more longer duration of time. So they're having the longer duration of activity. So these irreversible, they show their activity until the 3 to 4 days. So that is the difference between the reversible and irreversible. So in selective alpha 1 blocker, that is the prazosin, terazosin, doxazosin. So these are the drugs which comes under the selective alpha 1 blocker. And in case of reversible, tolazoline, phentolamine, these are the reversible non-selective alpha blockers. And dibenzamine, phenoxybenzamine, these are the drugs which comes under the irreversible non-selective alpha blockers. So this is about the classification of alpha blockers, that is the selective and non-selective. Then we have seen the structure, tolazoline, phentolamine. Then we have the structure of phenoxybenzamine. Okay, so this is the phenoxybenzamine, that is the irreversible alpha blocker. So what happens in irreversible? So in case of phenoxybenzamine, what is the structure? Okay, so this is the structure. So here you can observe this structure is similar like what we have seen in the anti-cancer agent, that is the nitrogen mustard, that is the alkylamine structures, or you can say haloalkylamine structures. Okay, if such structures are present, that is the structure of phenoxybenzamine, which is the irreversible. So such structures are present. What happens? It forms a aziridinium like structure, or aziridinium ion. So this chlorine removes, and this carbon, it binds to this nitrogen. So what happens due to the binding of these two? That one, here you can observe this structure. So the NCH2 and CH2, and this N becomes the positive as it having the more carbon or more bond attached to the nitrogen. So it becomes the positive. So it is the aziridinium ions. And when it comes in the contact with the nucleophile, so here nucleophile is the adrenergic receptor. So when it comes in the contact with the adrenergic receptor, that is the nucleophile, then this bond breaks and this carbon, it binds to that nucleophile, and due to the binding it forms the alkylation of that receptor, and the alkylation is the strong covalent bond, so it is difficult to break that bond. So it becomes the irreversible alpha blockers. Okay, so that is the mechanism what takes place in case of irreversible. Okay, here you can observe aziridinium ion will form, then it look for the nucleophile which is present on the receptor. So this binds to that nucleophiles, and alkylated receptor is present. So alkylated receptor, that means it having the covalent bond with the receptor, so it blocks the alpha receptor. So it generally shows 3 to 4 days their activity until it detaches from the receptor. So that is about the non-selective alpha blockers. Now we will move to the next part. It is the selective alpha 1 blockers. Okay, so selective alpha 1 blockers, they are generally comes or they are classified depending upon the structure, and one of the class that is having the zosine in their name and another class which having the osine in their name. So they are generally classified into these two parts where they having the zosine in their structure, another part where there is having the osine in their structure. So the zosine means the prozosine, terazosine, doxazosine. So these are the drugs which comes under the alpha 1 blocker, and osine means siladosine, then tamsulosin. So these are the alpha 1 selective blockers having the osine in their structure. Okay, now we will see one by one. That is the these zosine is generally structure which are utilized or it is useful as a vasodilator, and due to the vasodilation it decreases the blood pressure. So generally as antihypertensive agents these drugs can be used. While these osine containing drugs, that is the tamsulosin and silodosin, they generally blocks alpha 1 A receptor, selectively alpha 1 A receptor, and it is used in the treatment of BPH, that is the benign prostatic hyperplasia. So it causes more urination. So due to the urination, it is useful for the healing the symptoms of prostatic hyperplasia. So generally, they are useful in the treatment of BPH, it is the benign hyperplasia. Okay, so this is about the some general information regarding the selective. So they are selective, they block only the alpha 1 receptor, so they consider the selective alpha 1 blocker. Now we will move to the part that is the zosine. There is a prozosine, terazosine and a doxazosine which is present in the structure. So they generally having the quinazoline in their structure. So I will draw the structure. Here OCH3, OCH3 are present. There is the two methoxy groups are present. Then this is quinazoline ring. This quinazoline ring binds to the piperazine ring, and this piperazine binds to the acyl ring. So here double bond O is present. Okay. So this ring is quinazoline ring. This is piperazine ring. This is COR, that is the acyl part. And to this quinazoline ring there is a presence of NH2. So that is the complete structure of the drugs which comes under the zosine in their alpha 1 blocker. Okay, so numbering generally starts from one of the nitrogen which is present at this position. So numbering starts from this one, this is 1, this is 2, this is 3, this is 4, this is 5, this methoxy group is at 6, this methoxy is 7, this is 8. So that is the numbering. Okay. So in case of quinazoline, the quinazoline ring is necessary, and along with the quinazoline, the amine part is necessary. So this amine part is actually required to bind to the receptor. So that's why this is essential for the alpha 1 blocker. Then the piperazine ring, which is present at the center, this piperazine ring we can easily replace by another ring like piperidine ring, or instead of cyclic we can only produce the alkyl amino chain. Okay, so it is not necessary that piperazine ring must be there. So piperazine ring we can change or we can replace by the piperidine ring or by the simple alkyl amino chain. And this acyl part, that is the final part which is present in the structure, हा जो शेवटचा पार्ट आहे acyl part, it is the required for the pharmacokinetic properties. So this pharmacokinetic property of drug is depending upon this part. So duration of activity, the bioavailability is depending upon the this part. Okay, that is the which groups are present on the acyl part, that is the R. Okay. Okay, here you can observe the basic nucleus which is required for the selective alpha 1 antagonist. That is the quinazoline ring is there, piperazine ring is there, 4 acyl moiety is there, and there is a 4 amine group is there. The 4 amine group is actually required for the binding to the receptors. That is the essential for the activity. While piperazine ring, this piperazine ring is not actually necessary for the activity. So this piperazine ring we can replace by the piperidine ring or simply by the straight chain alkyl chain we can replace. Then mainly point, that is this acyl point, that is the COR. This acyl point is required for the pharmacokinetic effect. So the pharmacokinetic, that is the duration, their bioavailability, is depending upon the this acyl part. Okay. So we will see the drug one by one. Okay. So if R is furan ring, okay. So if R is this ring, that is the furan ring, then the drug becomes prozosine. What is the drug? It becomes the prozosine when R is furan ring. Now go for the nomenclature. Write down the chemical name. So it is actually the ketone. So C double bond O, that is the ketone part, that is the methyl with oxygen. So such compound is called as methanol. Okay, so that is the methanol. So तुमचं जे नॉमेनक्लेचर येणार आहे ड्रगचं, त्याच्यातलं शेवटचं पार्ट काय असेल, दॅट इज द methanol. Then this methanol or C double bond O, at one side it has this ring and other side it has furan ring. ओके, एका साइडला काय आहे, फ्युरान रिंग आहे, एका साइडला काय आहे तुमची ही पूर्ण रिंग. सो द फ्युरान रिंग एका साइडला आहे. सो फ्युरॉन रिंग म्हणजे त्याला सबस्टिट्यूशन आहे. सो इट बिकम्स फ्युरॉनिल. आणि फ्युरानच्या कुठल्या पार्टला, तर ह्या सेकंड पोझिशनला सबस्टिट्यूशन आहे. सो ड्रग्स बिकम्स फ्युरान 2 methanol. ओके, लक्षात आलं हाऊ टू गिव्ह द नॉमेनक्लेचर. एका साईडला फ्युरान रिंग आहे आणि एका साईडला तुमची ही पूर्ण रिंग स्ट्रक्चर आहे. सो ड्रगचं नाव काय झालं, फ्युरान 2 मिथॅनॉल. सो दॅट इज द दिस पार्ट. हा पार्ट इकडचा झाला. आता उरलेला हा पार्ट. त्या पार्ट मध्ये काय आहे, ही रिंग आहे, बरोबर आहे. दॅट इज द क्विनॅझोलिन रिंग आणि हे दोन मिथॉक्सी ग्रुप आहेत. सो काय झाले, डायमिथॉक्सी. आणि फोर्थ पोझिशनला इथं अमाइन ग्रुप असतो, बरोबर आहे. सो 4 अमायनो डायमिथॉक्सी क्विनॅझोलिन 2 इल. हे कुठल्या पोझिशनला, हे 1 हे 2 दोन पोझिशनला सबस्टिट्यूशन आहे. सो 2 इल. लक्षात आलं मी काय म्हणतोय तो. सो राईट डाऊन 4 अमायनो, ओके, डायमिथॉक्सी, हे दोन मिथॉक्सी झाले. 4 अमायनो डायमिथॉक्सी 2 इल. ओके, आता हा पार्ट संपला. आता राहिला फक्त पायप्राझिन पार्ट. पायप्राझिन कुठल्या पोझिशनला आहे, 1 पोझिशनला हे सगळं सबस्टिट्यूशन आहे. सो 1 इल, that is the piperazine 1 ill. So that is the chemical name for this ring, that is the prozosine. लक्षात आलं हाऊ टू नॉमेनक्लेट. तुम्हाला एक्झाम मध्ये ह्याचं स्ट्रक्चर दिलेलं असतं. तुम्हाला आयुपॅक नॉमेनक्लेचर विचारणार किंवा केमिकल नॉमेनक्लेचर विचारणार. अलॉंग विथ दॅट कुठलेही क्वेश्चन विचारताना ते काय काय डायरेक्टली तुम्हाला विचारणार नाही. गिव्ह द थेरापेटिक युजेस ऑफ प्रोझोसिन. दे विल से गिव्ह द थेरापेटिक युजेस, त्याचं केमिकल नेम देतील आणि सांगतील गिव्ह द थेरापेटिक युजेस ऑफ दिस. व्हॉट इज द थेरापेटिकल नेम. दिस इज फायनल पार्ट, फ्युरॉन 2 वाईल मिथॅनॉल. ओके, त्याच्या आधी काय, 4 अमायनो डायमिथॉक्सी क्विनॅझोलिन 2 इल, piperazine 1 ill, furan 2 ill, methanol. So that is the structure of prozosine. Okay. So here you can get the complete name. That is the 4 amino dimethoxyquinazoline, piperazine 1 ill, furan 2 ill, methanol. So that is the structure of prozosine. Okay, what is that? That is the structure of prozosine, or that is the nomenclature for the prozosine. Now, if this R group is this group, त्या फ्युरान मधले फ्युरॉनचं रिडक्शन करायचं. रिडक्शन केले की डबल बॉन्ड आहेत ते रिमूव्ह होतात, त्यामधले डबल बॉन्ड आहेत ते निघून जातात. So if we reduce the furan ring, it becomes tetrahydrofuran. And if this tetrahydrofuran structure, if it is present in case of R, prozosine is having the furan ring, terazosine is having the tetrahydrofuran ring. That is the reduction of furan ring. We are making the reduction, and after reduction, if that tetrahydrofuran ring is attached at that position, so what happens? Remaining all the nomenclature remains same. That ring, this ring is called as oxalone. So the nomenclature becomes 4 amino dimethoxyquinazoline 2 vial, piperazine 1 ill, furan च्या ऐवजी फक्त oxalone 2 vial, methanol. So that is the nomenclature for the terazosine. लक्षात आलं. बाकीचं सगळं स्ट्रक्चर सेम आहे, फक्त चेंज काय होणार, जिथं फ्युरान रिंग आहे तिथं फक्त टेट्राहायड्रोफ्युरॉन रिंग येणार. And that tetrahydrofuran ring is called as the oxalone ring. That's why only the nomenclature furanil 2 vial चे इथं फक्त oxalane 2 vial एवढंच आहे. That is the exchange, or that is the change which takes place in the furan ring. So furan 2 ill, it will replace by the oxalane 2 ill. So that is the nomenclature for this terazosine. Now this terazosine and prozosine, only the one change is there, that is the reduced furan ring is present, that is the tetrahydrofuran ring is present, and if such ring is present, that ring becomes more hydrophilic. So that is the 20 to 25 times hydrophilic as compared to the protosine. That's why it having the more or longer duration of activity as compared to the protosine. So the terazocine, it is the tetrahydro, it is reduced form, so it having the more hydrophilicity. Due to the hydrophilicity, due to the water solubility, it having more activity or more or longer duration of activity as compared to the protosine. So that is the important part, that is the important question. There is a compulsory question on this part. That is, what is the structural difference between the protosine and terazocine? Or they may ask what is the therapeutic or what is the difference in the pharmacokinetics of protosine and terazocine. So what is the pharmacokinetics or how you can explain the pharmacokinetics? So that acyl part they having the R group. This R group is required for the or it is necessary for the pharmacokinetic properties. So if R is having the furan ring, it becomes the protosine. If R having the tetrahydrofuran, that is the reduced furan ring, it becomes the terazocine. And in case of terazocine, as it is the reduced form or the reduced structure, it having the more hydrophilicity as compared to the protosine. Hence, it shows more or longer duration of activity as compared to the protosine. So that is the compulsory question. एक तर structural difference विचारना किंवा दूसरा pharmacokinetic difference between protosine and terazocine. As both the drugs, they are the alpha 1 selective blockers. Okay, so that is the difference. So they will ask structural difference or they will ask the pharmacokinetic difference between the protosine and terazocine. So right, make it important question. That is a compulsory question for 1 or 2 marks. Now, if this R is this structure, हे R जर हे structure असेल, so what will be the nomenclature? सगळं पार्ट आहे तो सेम, फक्त जिथं फ्युरान आहे, ऑक्झॅलिन 2 आहे, तिथं काय येणार 2,3 डायहायड्रो 1,4 बेन्झ डायऑक्सिन 2 वायल. ओके, बाकीचं सगळं नॉमेनक्लेचर असं 4 अमायनो डायमिथॉक्सिक्विनाझोलिन 2 वाईल पायप्राझिन 1 आयल. फक्त फ्युरान असेल तिथं फक्त काय ना 2,3 डायहायड्रो 1,4 बेन्झो डायऑक्सिन 2 वाईल मिथॅनॉल. So that is the nomenclature or that is the chemical name for this drug, that is the doxazocine. Okay, so protosine ला फ्युरान 2 वाईल येणार, टेराझोसिन ला ऑक्झॅलोन 2 वाईल येणार आणि डॉक्साझोसिन ला काय येणार 2,3 डायहायड्रो 1,4 benzodiazepine 2 while. So that nomenclature will given to the doxazocine. Are you getting my point? तुमचं nomenclature clear झालं. याच्यावर nomenclature वर पण match the following साठी compulsory question विचारला जातो. Okay, so furan 2 while, protosine, oxalone 2 while, terazocine 2,3 dihydro 1,4 benzodiazepine 2 while. It is the doxazocine. So these three drugs which comes under the selective alpha 1 blockers, it is the protosine, terazocine and doxazocine. Okay, so this is about what we have seen regarding the selective alpha 1 blockers. They are in the zocine part, they are in the ocine part. Zocine मध्ये protosine, terazocine and doxazocine येतो. नुसतं ocine मध्ये tamsulosin and silodocine येतो. These are useful in the treatment of BPH. It is also called as benign prostatic hyperplasia. While these zocine, protosine, terazocine, they are doxazocine, they are the alpha 1 blocker and they will come under the, they will cause the vasodilation. So due to the vasodilation, the blood pressure decreases. So they act as the antihypertensive agents. Okay, so that is the examples of alpha 1 blocker, that is the protosine, terazocine and doxazocine. Okay, so I will again revise in brief. The alpha blockers, they are classified into two types. One is the selective alpha blocker, second one is the non-selective alpha blocker. Selective alpha blockers, that is the selective alpha 1 blocker. Example, protosine, terazocine and doxazocine. And non-selective, they are again classified into two types, that is the reversible and irreversible. So irreversible, which binds to the receptor by the alkylation process, they forms a covalent bond, so it cannot be detached easily from the receptor. For example, it's phenoxybenzamide. In case of reversible, they bind to the receptor and after completion of activity, they can be detached from the receptor. So they having the limited duration of activity as compared to the irreversible. For example, tolazone, phentolamine. So these are the examples which comes under the non-selective reversible alpha-1 blocker, and phenoxybenzamide is the non-selective irreversible alpha-1 blocker. Okay. Now, before moving to the next part, that is the beta blocker, we are going for to see the metabolism as well as the how the synthesis of neurotransmitter, that is adrenaline, noradrenaline, takes place, how the metabolism of this neurotransmitter takes place. That we will see. Generally, for 2 or 3 times this question is asked. That's why I'm covering this part. It is asked for 2 to 3 marks. Okay, give the synthesis and metabolism of neurotransmitters. So such questions they are asked in the exams. Okay, so the all the neurotransmitters, they are generally synthesized from the amino acid. So similarly, these neurotransmitter adrenaline, noradrenaline, they are also synthesized from an amino acid. It's called as phenylalanine. This phenylalanine undergo hydroxylation at para position. So here you can observe hydroxy group, and then it is converted into the another amino acid. That amino acid is called as the tyrosine. Again, the hydroxylation takes place and it forms a catechol nucleus that is called as dopa. The structure is called as dopa. So in this way, phenylalanine, it undergo hydroxylation, it forms tyrosine. Tyrosine undergo again hydroxylation to form a catechol nucleus, that is the dopa. In the dopa, there is a decarboxylation of this group takes place and it forms the dopamine. So already we have covered the synthesis of dopamine as well as the metabolism of dopamine in the chapter anti-Parkinson. So similar kind of synthesis takes place for the dopamine, and from dopamine there is a synthesis of noradrenaline and adrenaline takes place. Okay, so in the dopamine there is a hydroxylation of this beta carbon takes place and it forms this type of structure. That structure is called as noradrenaline. In case of noradrenaline, the terminal amine is having NH2 group. Then again there is the addition of CH3 group in the terminal amine takes place and it forms NCH3, that is the methylation of noradrenaline takes place and it forms NHCH3, and such group they are called as adrenaline. So from dopamine it forms noradrenaline, and noradrenaline it undergo methylation by the N-methyl transferase and it forms adrenaline. So in this way the synthesis of adrenaline and noradrenaline takes place from the amino acid, that is the phenylalanine, tyrosine, then dopa, from dopa to dopamine, from dopamine to the noradrenaline, from noradrenaline to it forms the adrenaline. So in this way the synthesis takes place. Now we are moving to the next part, that is the metabolism. So what happens in the metabolism? So as we know, if it has a catechol nucleus, it can undergo metabolism by the enzyme called as COMT, that is the catechol O methyl transferase. So as the name indicates, catechol O means a catechol nucleus मधला जो hydroxy group आहे त्यातला एक oxygen, their methyl transfer, that is the transfer of methyl group at that oxygen takes place. So that hydroxy group, it will converted into the OCH3. So similar kind of reaction takes place in case of adrenaline and noradrenaline, that is their hydroxy group, they undergo the metabolism by COMT and they are converted into the OCH3. So here you can find OCH3, OCH3. So that is the first metabolism of adrenaline as well as the noradrenaline. It is their metabolism by catechol-methyl transferase takes place. So in this way this takes place. And then if the neurotransmitter, they have the amine group at the terminal part, then it can undergo the another kind of mechanism that is called as metabolism by MAO, that is the monoamine oxidase, that is the oxidation of amine group. So in case of oxidation of amine group, the removal of amine group takes place, and penultimate to that the carbon is present. That carbon undergo oxidation and it will converted into the carboxylic acid. So such type of metabolism we can observe in case of neurotransmitter, that is the monoamine oxidase. So here NH2 group is present. So this NH2 group is removed. Here you can observe this NH2 group is removed, and this CH2 it undergo oxidation and it forms COOH. So this is the structure of metabolism of noradrenaline after the oxidation. Similar structure you can observe after metabolism of adrenaline. That is, this NCH3 group removes and this CH2 it is converted into the COH like this one, and we are getting the similar kind of structure what we have seen after the MAO metabolism by the of the noradrenaline. So similar structure we can observe. So these adrenaline, noradrenaline, after COMT, they undergo monoamine oxidase metabolism and they form a similar kind of structure. That structure is called as mandelic acid. So in this way, the metabolism of adrenaline, noradrenaline takes place. Metabolism of dopamine already we have covered in the part that is the anti-Parkinson agent. So these adrenaline, noradrenaline, they undergo metabolism by COMT, and after COMT they undergo metabolism by MAO, that is the monoamine oxidase, and they are got the similar kind of structure, that is they are having the mandelic acid. So I will just draw the structure. CHOH, here OH, here OCH3, here OH. So this is the end metabolism of adrenaline and noradrenaline by COMT as well as the monoamine oxidase. And such structure is called as mandelic acid. So here at the third position hydroxy group present, at the fourth position methoxy group is present. So the such structure is called as 3-hydroxy 4-methoxy mandelic acid. So that is the end product or the end metabolism product of adrenaline and noradrenaline after COMT metabolism and after the monoamine oxidase metabolism. Okay, so in this way the synthesis and metabolism of adrenaline and noradrenaline takes place by the enzyme COMT and the MAO. So they are synthesized from phenylalanine to the tyrosine, from tyrosine to the dopa, from dopa to the dopamine, then noradrenaline, then adrenaline. And both these adrenaline, noradrenaline, they undergo metabolism by COMT, and after undergoing metabolism by COMT, they are sequentially undergo metabolism by monoamine oxidase to form a single metabolite product, that is the 4-methoxy 3-hydroxy or 3-hydroxy 4-methoxy mandelic acid. So that product you are getting. Okay, so this is about the metabolism. Now the next part, that is the beta blockers. So details according to the beta blockers that we will see in the next lecture. So beta blockers, it is said that during the researchers, that is the beta blockers have similar kind of structure what we have seen in case of adrenergic agonists, that is they having the this kind of structures. Okay, here substitutions. Okay, here hydroxy group. So such kind of, this is the adrenergic agent. R1 R2 is hydroxy group, it becomes catechol nucleus, they becomes the agonist. So here we have to replace R1 R2 by the another group, or we have to remove the R2 group or R1 group, and then we have to replace other group. So hydroxy group जर आपण remove केला, then we will get the antagonist, as well as if this NHR, that is the R group, is it is the bulky group or more substitutions, then the drug becomes more antagonist or more potent antagonist. Okay, so details regarding these beta blockers, how the SAR of these beta blockers takes place, how the changes takes place, that we will see in the next lecture. Okay, now we will stop here.